many one. So before going to the next questions, if you are facing a problem with any question, any past question or anything, any concept, please feel free to ask me. Then only we will start whatever we are going to start in this class. तो जो भी पूछने का है यार खुल दिल खोल के पूछा करो, क्लास में कोई दिक्कत नहीं है, डरने का तो कोई बात ही नहीं है यार. मतलब आई अंडरस्टैंड दैट यू विल नॉट गेट एवरीथिंग इन द फर्स्ट अटेम्प्ट. मतलब nobody gets in the first attempt. There are some things which you need to work on consistently, then only you will be able to get those things. So it is not at all a problem if you didn't get anything. Please just ask me. Okay, so I'm assuming that you guys don't have any problem. If you have, please feel free to chat me. You can just write your problem in the chat box. If you're not speaking up, then it's okay. You can write the problem in chat box, and then I'll be taking your problem. I will try to make you understand what are we doing and why we are doing. But before that, let's take a quick revision what we have done. So we are trying to identify whether a given function is one or many one, and CBSE, or rather our NCERT, suggests that you can do this by taking two arbitrary constant first. So you take x1 and x2 as two constants which belongs to the domain of the function. Now domain can be anything, but in most of the cases domain will be given to you. So you take two values from the domain, you name them x1 and x2, and then you start okay. So the concept is, if you understood the last class, then I will tell you the concept why we are doing this.
Sir,
Yeah, Chavez.
sir, I was not there in last class, sir. I thought it was not.
Yeah, I know you were not present in the last classes. So मैं अभी तेरे को बता देता हूँ. देखो अभी हमने क्या किया. Austin, just give me 2 minutes, okay? I'll speak in Hindi so that they can understand easily what we have done. हम लोगों ने before I mean the class before yesterday, we understood what are the types of functions: one, many one, onto, and into. Now the first part is to identify whether a given function is one or many one. So how do we start? We take two arbitrary constant, just like this fifth question which we have solved here. We take two arbitrary constant x1 and x2 which belongs to the domain of the function for which we want to identify whether this is a one or onto. So here we are given a function fx which is equal to x cube. So the expression of the function is x cube. Now we need to know what is the domain and range, or sorry, domain and codomain of the given function. So domain is this first set. So a function is represented like this. And then we tell the expression of the function. So this is the expression of the function. And the first thing tells us the name of the function, which is f. And second is this z denotes the domain of the function. So basically set of integers, in this case, in the given fifth question, set of integers which is represented by z, set of integers is the domain, and set of integers is the codomain, z and z. So first is domain. This is domain of the function. And this set is represents codomain of the function. तो हम करते क्या है, हम दो कोई भी कांस्टेंट उठा लेते हैं. अब कोई भी कैसे उठाएंगे यार? कोई भी का मतलब है कि हम कोई अननोन कांस्टेंट्स ले रहे हैं, x1 and x2. We start by taking two unknown constants x1 and x2 which belongs to the domain of the given function. अब देखो हम डोमेन से बिलोंग क्यों करा रहे हैं? हम क्यों कह रहे हैं कि दो इनपुट लो which should belong to domain? Why? Because domain क्या है? What is domain? Domain is the input of your function. So whatever you are taking, जो भी x1 x2 तुम ले रहे हो, that should belong to the domain because that should be the input of the function. अभी मैं इस फंक्शन के बारे में बात कर रहा हूं, तो इस फंक्शन के बारे में बात कर रहा हूं तो मैं इसमें ऐसी ही वैल्यूज दूंगा ना जो इसके डोमेन में होंगी, क्योंकि इसको आप वही वैल्यूज दे सकते हो जो डोमेन में है इसके, बिकॉज डोमेन रिप्रेजेंट्स द सेट ऑफ ऑल इनपुट्स ऑफ अ फंक्शन। तो मैं इसको कोई इनपुट देना चाहता हूं अगर, तो दैट इनपुट शुड बिलोंग टू द डोमेन। सो दैट इज व्हाई आई स्टार्टेड बाय टेकिंग टू unknown constants which belong to the domain of this expression or domain of this function. So I started with x1 x2. All these first two lines are always same for any function. Okay, so we'll start by taking two unknown constants x1 and x2 which belongs to the domain. Domain in this case is z, which is integer. तो हमने बोला कि x1 x2 दो unknown constants हैं जो हमारे डोमेन को बिलोंग करते हैं। And right now the assumption is that x1 and x2 both are different. I mean, we don't know about x1 and x2. So the first thought should be they are different. They can be same. I'm not saying that they can't be same. But the first thought should be that x1 and x2 are different. Right? Then we start by assuming that both of these inputs gives the same output. Why did we do so? Because we wanted to understand whether the function is one or many one. How do we know a function is many one? If there are two inputs, which gives the same output, then the function is known to be many one. So हमने ये बोला कि भाई x1 x2 कोई दो वैल्यू थी और हम ऐसा मान रहे हैं कि इन दोनों पे आउटपुट सेम आ रहा है।
Sir,
Yes.
the function is like input is more than one, so then it will be
शाविज,
many one.
सॉरी तेरी आवाज क्लियर नहीं है, फिर से बोल।
Sir, if the input is more than one, so it will be many one.
हाँ, एज मतलब अगर कोई भी फंक्शन है जिसके अंदर दो या दो से ज्यादा इनपुट रखने पे सेम आउटपुट आता है, then that function is known as many one function. ठीक है, अब मैं ये चेक करना चाहता था कि ये many one है कि नहीं। तो many one चेक करने के लिए बहुत सिंपल सा रूल ये है, आप कोई भी दो इनपुट उठाओ और बोलो कि इन दोनों पे सेम आउटपुट आ रहा है, ऐसा मैं मान के चलूंगा स्टार्टिंग में। तो I would assume that both of these inputs are producing the same output. That is why यहां से हमने स्टार्ट किया, ये था हमारा assumption that fx1 and fx2 both are same. fx1 is basically the output at x1 and fx2 is basically the output at x2. So I'm assuming that both the outputs are same. Now अब अगर इस इक्वेशन का अकॉर्डिंग टू द एक्सप्रेशन, सबसे पहले आप इसको सॉल्व करोगे तो fx1 आपने यहां से निकाल लिया x1 क्यूब आया, fx2 आपने निकाल लिया x2 क्यूब आया, राइट। अब आप इस इक्वेशन को सॉल्व करोगे और अगर इस इक्वेशन को सॉल्व करने के बाद सिर्फ एक ही आंसर आता है, सिर्फ और सिर्फ एक आंसर आता है, विच इज x1 इज इक्वल्स टू x2। तो इसका मतलब ये हुआ कि यार अगर आपका आउटपुट सेम था ना fx1 और fx2, if your output was same, then that is only possible when your inputs were same, that is x1 is equals to x2. So आपका आउटपुट सेम हुआ, इसका मतलब आपका इनपुट भी सेम था, तब तो हुआ ये 1-1 अगर सिर्फ एक ही आंसर आया। और अगर एक से ज्यादा आंसर आता है, जो कि पॉसिबल है, आ सकता है,
Sir,
तो
can I
जो
repeat
एक,
again?
yes, अगर so we will start by taking two unknowns x1 and x2 and we will assume that both of these unknowns or both of these inputs are producing the same output. तो first two lines will always be same, Chavis. x1 x2 हम कोई भी दो इनपुट उठाएंगे और assumption लेंगे कि fx1 और fx2 दोनों की वैल्यू इक्वल है। अब अगर हमारी ये assumption सही हुई, सॉरी what I want to say is कि अगर हमारी इस assumption का आंसर सिर्फ एक आता है, which is x1 is equals to x2, तो इसका मतलब ये है कि देखो आपका आउटपुट सेम था fx1 और fx2, तो आपका इनपुट भी सेम है। मतलब सेम ही इनपुट पे सेम आउटपुट आ सकता है, ऐसा कोई दूसरा इनपुट नहीं होगा जिसमें सेम आउटपुट आ जाए। तो इसका मतलब फंक्शन हुआ 1-1। बट अगर एक से ज्यादा आंसर आते हैं, जैसे कि एक आंसर आया x1 is equals to x2, for example let's take this, yeah, first question। तो इस केस में हमें fx is equals to x square के लिए देखना था। Now as soon as we started solving it, we got two answers after solving the whole equation. One answer is x1 is equals to x2, this one, right? And second answer is x1 is equals to minus x2. So there are two answers to this question. तो मैं बोल दूंगा यार कि ये दो आंसर आ रहे हैं इसलिए फंक्शन मैनी वन है। वाई मैनी वन? क्योंकि देखो ये x1, सी दिस x1 is equals to x2 says that if output was same, input has to be same. Okay, this is the condition of 1 1. But this second condition represents that if x2, you put x2 any value, then x1 can be negative times of that value to give you the same output. What does that mean? That if you find the answer of, or if you give 2 as the input of this question, then -2 will also represent the same output, which is true in this case. You can see that. If you put 2, then also answer 4. If you put -2, then you also get the output as 4, which is represented by the second equation. That if you give any value to x2, your x1 can take negative times of that to produce the same output. Right? So there were two answers. और अगर मैं बिल्कुल देसी भाषा में बोलूं तो एक आंसर आता है x1 is equals to x2, तो 1 1 है। एक से ज्यादा आंसर्स आते हैं तो ये 1 1 या मैनी वन में से कुछ भी हो सकता है। So if there is only one answer, then the function is 1 1, and the answer should be x1 is equals to x2, right? But if there are more than one answers, then it can be either 1 1 or many one. How do we know now whether it is 1 1 or many one? We will see, apart from this solution x1 is equals to x2, all the other solutions are valid or not valid. Now what does this mean, valid or not valid? Now see, in this case, you give x2 a value from the domain. Your domain was set of integers here. So you give x2 a value from set of integers, any value from set of integers. Let's take 3. Okay. So as soon as I put x to 3, your value of x1 is -3. Right? तो आप एक वैल्यू दोगे x2 को और चेक करोगे कि जो उस x2 के करस्पॉन्डिंग x1 आ रहा है सॉल्यूशन के अकॉर्डिंग. So let's say I put x2 as 3, then x1 will come as -3 according to the solution. So I will check the x1 corresponding to a particular value of x2 is in the domain or not in the domain. So for example, if I put x2 here 3, then x1 would be -3. So I would check whether -3 is a part of the domain or not. Now the domain is set of integers and x1 is -3. Is -3 an integer? Yes. If -3 is an integer, then it comes inside the set of domain. That is, you can put or you can give x1 the value -3. आप x1 को -3 पुट कर सकते हैं. क्यों? क्योंकि वो डोमेन का हिस्सा है, वो डोमेन का एक पार्ट है. तो इसका मतलब ये सेकेंड सॉल्यूशन पॉसिबल है. और सेकेंड सॉल्यूशन पॉसिबल है, which means that there are two solutions to this equation now, which means that the given function is many one. Now let's take second case. In the second case, the function is same, but I have changed the domain. Now the domain is your natural numbers. We can only give the input a natural number. Now what does change? कुछ चेंज नहीं हुआ यार, सेम सॉल्यूशन है बिल्कुल. देख लो, मतलब सेम ही होगा सॉल्यूशन, तो अलग थोड़ी हो जाएगा. जब सेम एक्सप्रेशन है तो सॉल्यूशन तो सेम होना ही होना है. तो मेरे पास फिर से आंसर दो आए, x1 is equals to x2, x1 is equals to -x2, just like the previous question, right? Now this is true, ये तो this will always be true, right? Now we have to check whether this second solution is valid or not valid. How do we check? You give x2 a value. Now what are the values that you can give to x2? x2 is x2 belongs to the set of natural numbers, right? This time the domain is natural numbers. So as soon as you give x2 a value from natural numbers, let's take 2. I have shown the example of 2. So let's take 2. As soon as you put x2 as 2, the value of x1 is -2. But can x1 be -2? No. This time x1 cannot take the value -2. Why? Because x1 and x2 both has to be from the set of domain. And what is the set of domain? Natural numbers. So x1 is equals to -2 is not possible. Now someone can say that you can put x2 as -2.
You can just say one second.
Sorry. I'm
Can
saying
you
that,
repeat?
yeah, So I was saying that as soon as I put x2 as 2, अभी मैंने x2 को 2 रखा, देखो पहले तो मैं x2 को क्या क्या वैल्यूज दे सकता हूं, मैं x2 को कोई भी नेचुरल नंबर पुट कर सकता हूं, राइट, क्योंकि x1 x2 दोनों हमारे डोमेन का पार्ट है। तो मैंने x2 को कोई भी एक नेचुरल नंबर दे दिया, कोई भी नेचुरल नंबर आप उठा सकते हैं, मैंने लिया है 2। अब जैसे ही मैं x2 को 2 रख रहा हूं तो x1 की वैल्यू आ रही है -2। तो ये कहना चाहता है कि अगर आप x2 को 2 रखोगे और x1 को -2 रखोगे तो दोनों केस में सेम आंसर आएगा। मैंने कहा रुक जा भाई, रुक जा रुक जा रुक जा, पहले यही रुक जा जरा, x1 तो -2 हो ही नहीं सकता। क्यों? क्योंकि x1 डोमेन का पार्ट है। यस, एग्जैक्टली शाविस, x1 and x2 both has to be from natural number. So x1 is equals to -2 is not possible in this case because x1 and x2 both has to be from the set of natural numbers. So hence, in this case, this solution is not valid. This second equation is not valid because this does not satisfy the condition of domain. So there is only one solution. This is not possible. There is only one solution. And if there is only one solution, right? If there is only one solution, and which is x1 is equals to x2, then the given function is 1, 1. So the concept is this, that if there are more than one solutions, it means that there are more than one inputs which produces the same output. And if there is only one solution, it means that there will be only one input which produces one output. Simple सा concept तो यार ये है, इतना है. Now also think practically. Like in this case, second question, the input is only natural numbers. So natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? If you put 1, you get answer 1. If you put 2, you get answer 4. If you put 3, 9, 4, 16, 5, 25, right? Now you can see there is no value which will produce, or there are no two values which will produce the same output. As soon as you are increasing in number, your output is also increasing. You can start with minimum value must be 1 because the smallest natural number is 1. So you'll start with 1, 2, 3, 4, 5. As soon as you increase, your value also, your output also increases. So in this case, when the domain is natural numbers, the given function is 1, 1. That is why I told you when we were studying 1, 1 and many 1, that 1, 1 and many 1 is a property of domain. If you change the domain for the same expression, it may be possible that your type of function also changes. You can observe that. You have an example for that in front of you. In the first case, our domain was z to z. Our domain was set of integers, z. The function was same, x square. And you observed that the given function was many 1. But the same expression, same function for the domain of set natural numbers is a 1, 1 function. That is why we say 1, 1 and many 1 is a property of domain, is a property of input. And onto and into is the property of range, or rather, I mean, range or codomain, whatever you want to say. So if your domain is changing, it may be possible that the type of function can also change from 1, 1 to many 1 or many 1 to 1, 1. Both sides can be possible, right? So this is the main concept कि यार हम start करेंगे x1 x2 से, assume करेंगे fx1 और fx2 दोनों बराबर है. अगर fx1 fx2 बराबर हैं तो इसका एक ही आंसर आना चाहिए कि x1 is equals to x2. अगर आउटपुट सेम है तो इनपुट भी सेम होना चाहिए. There should be no more answer other than x1 is equals to x2. And if there are other answers, then they must not be valid in the given domain. If that is the condition, your function is 1, 1. If there is any other condition, anything other than this, then your function will be many 1. Shaviz, did you get it? What are we going to do? Let's start with this question now. So yaar, sabse pehle to let's understand what is written here. So a function f is given to us, right? And its domain. This is its domain, right? Shaviz, did you get it? क्या चल रहा है? ठीक है, अभी और क्वेश्चंस के साथ और समझ आ जाएगा थोड़ा, एक दो क्वेश्चन करते हैं सॉल्व। क्या बोल रहे हो शाफिज?
From domain 3.
Yeah, right. So this is written like all real numbers minus, this is a sign for, or this is a sign of negative, in fact minus, right? Or we can also say that, we can also call it like all real numbers except माने without 3, all the real numbers without 3. So the domain is given to us that you can give any input other than 3, other than this value, whatever is written in the set, right? So this is read as all real numbers except 3. Except is for this hyphen, this is not hyphen, basically this is minus sign. Minus sign means we have subtracted 3 from the set of real numbers. We don't want 3, it means this, right? And why don't we want 3? Because if we put 3 in this expression, we get infinity, or rather not defined, because the denominator becomes 0 as at 3. You can observe this. As soon as you put the value of x3, the denominator is 0, and if the denominator is 0, then the function is not defined. No. So that is why this is the domain of the function. In 11th, we also understood how to find the domain. So I don't know whether you know about this or not, but all the students who are preparing for JEE, they must know, they must know how to find domain and range of a function. In fact, this is very easy, and they should, I mean, this should be on the tip of your hand, like they should be really fast how to find out domain and range of a function. All the students of JEE must know how to find domain and range of a function. They need to know this. They will be using this a lot of times. I can assure you, you will be using this at least 500 times if you are preparing sincerely for JEE. Okay. So whatever I say, yeah.
Like which chapter do we learn to prepare domain and range?
Functions, 11th and 12th, both of the chapters. Both the chapters will need function. Domain and range. Also, this pura unit yaar, ye calculus wala. So differentiation, integration, and functions. And ITF also. I consider them, all of these chapters are like similar. तो इन सब में आपको डोमेन रेंज का बहुत ज्यादा जरूरत पड़ेगा, और डोमेन रेंज तो आना ही आना चाहिए। मतलब हर साल एक क्वेश्चन आता है यार जेई मेंस में डोमेन रेंज पे। मतलब डोमेन रेंज या तो जेई मेंस में या जेई एडवांस में, दोनों में से कोई से एक में क्वेश्चन आएगा पक्का, डोमेन एंड रेंज का। हर साल से आ रहा है, जिस साल मैंने जेई दिया था तब से आ रहा है, तब से नहीं, उससे भी पहले से आ रहा है। तो जो डोमेन रेंज तो मतलब एकदम हमें पाना ही चाहिए, बहुत ही इंपॉर्टेंट चीज है। और आपको ये भी समझ आना चाहिए कि फंक्शन को हमने ऐसे क्यों लिखा हुआ है, ऑल रियल नंबर्स एक्सेप्ट 3 टू आर, r-3 टू r, है ना? ये r-3 टू r इसलिए लिखा है क्योंकि r-3 हमारा डोमेन है इस फंक्शन का। और आप निकाल सकते हैं किसी भी फंक्शन का डोमेन, अगर नहीं भी दिया होता तो भी हम निकाल लेते हैं इस फंक्शन का डोमेन क्या है, यही है जो इसने लिखा हुआ है। कैसे पता चलेगा? ये हमें कंडीशंस देखनी पड़ती हैं। एक कंडीशन होती है डिनोमिनेटर की, ये डिनोमिनेटर कभी भी 0 नहीं होना चाहिए फंक्शन का, क्योंकि अगर डिनोमिनेटर ही 0 हो गया, ऑस्टिन यू डोंट नीड टू नो दिस, आई एम जस्ट टेलिंग देम अबाउट सम कॉम्पिटिटिव एग्जाम. So if your denominator is 0, then the function is not defined, right? Any mathematician, or whenever you are reading maths, whenever you are solving maths, we don't want denominator to be 0. Why? Because we are unsure about this. What is this? We don't know how to divide from 0, and whatever we don't know, we try to avoid this. Maths का बहुत simple सा rule है. We don't यार हम लोग ज्यादा शहनशाह नहीं बनते, मतलब हमारे यहाँ ना बहुत सिंपल ही चलता है। जो पता है वही उसी में ही घुसते हैं, जो नहीं पता है उससे किनारा कर लेते हैं। हाँ जी, नहीं पता है बता देते हैं। मतलब मैथ्स तो यही कहता है, मेरे को पता नहीं पढ़ाने का तरीका, तो पर मैं तो बिल्कुल ऐसे ही हूँ, मेरे को नहीं पता होगा कुछ भी मैं बोल दूंगा मुंह पे कि मेरे को नहीं आता भाई ये, और जो पता होगा वो सही पता होगा। हमेशा यही करना है, मैथ्स पढ़ना भी इसी तरीके से होता है। तो मैथ्स में बहुत सिंपल से रूल्स हैं, और वहीं से ही ये सिंपल रूल आया है कि आपका डिनोमिनेटर कभी भी 0 नहीं होना चाहिए। यानी कि आप खुद से तो कभी डिनोमिनेटर को 0 नहीं बनाएंगे, और यहाँ पे अगर आपने x को 3 रख दिया तो देखो डिनोमिनेटर 0 बन जाएगा, है कि नहीं? So that is why we never So this is the first rule of your finding out domain. To find out the domain of a function, your denominator should not be equal to 0, right? तो हम find out भी कर सकते हैं ये सब चीजें तो खैर. And I have also uploaded these videos on YouTube. मेरी videos भी हैं और बहुत सारे और teachers की भी videos हैं. कहीं से भी पढ़ो, but ये सब चीजें आनी तो तुम्हें चाहिए ही चाहिए. Easy steps हैं, कोई बहुत बड़ी deal नहीं है. Okay, खैर. This were for all the JEE aspirants, yeah, or whatever exam you are preparing for. सीबीएसई में तो कभी आपसे कोई नहीं पूछने वाला क्या डोमेन निकालो या कुछ निकालो. 11th क्लास में पूछते थे, अभी तो कोई नहीं पूछेगा. सीबीएसई में दे वोंट आस्क यू अबाउट हाउ टू फाइंड डोमेन एंड रेंज. या हाउ टू फाइंड रेंज दैट वी विल डिस्कस, दैट यू शुड नो. खैर, लेट्स स्टार्ट विद दिस. So you want to identify whether the given function is one or many one. So where do we start? We will first consider two unknown values. Let's call these unknown values as x1 and x2, which belongs to our domain. What is the domain? Real numbers except 3. So I'm assuming these x1 and x2 are two values which belongs to the set of domain. What is the set of domain? Set of real numbers except 3, or set of real numbers minus 3. Okay. Now start by assuming that both of these values x1 and x2 are producing the same output. So fx1 is equals to fx2. Now let's start with this. fx1, what would be fx1? x1 minus 2 divided by x1 minus 3. And what would be fx2? x2 minus 2 divided by x2 minus 3. Both of these are equal. Now we have to solve them and find out the solution. So you can multiply them. x1 minus cross multiply them. So for cross multiplying, I'll be multiplying x1 minus 2 with x2 minus 3 and x2 minus 2 with x1 minus 3. So the solution will be like this: x1 x2 minus 3x1 minus 2x2 plus 6. And this is x2 x1 minus 2x1 minus 3x2 plus 6. x1 x2 and plus 6 can be cancelled out because they have same sign both sides. Now this minus 3x1 can be taken to the right hand side, and this minus 3x2 can be taken from right hand side to left hand side. So this will become like, if I take minus 3x2 to the left hand side, this becomes plus 3x1. And if I take minus 3x1 to the right hand side, this becomes plus 3x1. Now we are left with minus 2x2. Sorry, my bad. Wait a minute. Yeah. So I'm taking minus 3x2 to the left hand side. So this becomes plus 3x2. And I'm taking minus 3x1 to the right hand side. So this becomes plus 3x1. Now we are left with this and this because we didn't change them. So this becomes x2 is equals to x1. Now you can check, there is only one solution to the given equation, which is x1 is equals to x2. There is only one solution. We don't have more than one solution for this. That is why we can say that given function is 1, 1. Because there is only one solution to the question. And in this similar way, we can start with the question to identify whether that represents a 1, 1 function or many one function. Acha, now let's try some difficult ones. एक डंडा रख दिया उस पे. Yeah, it's okay, Faisal. It's cool. Just whenever you rejoin, just text me a message. Hanji, chalo. Check for this one. F is a function given from R to R. That is set of real numbers to set of real numbers. And your fx is mod x. Solve this one. Yes, both of you are correct, Shahid and Mahmuddin. Now, Shahid, we call it as not 1-1 rather than not 1-1, we call it as many one, no? But the more interesting part is why? How? शाहिद और मामुद्दीन में से कोई भी मेरे को समझा सकता है why? How do you identify? देख यार, मेरे को ये सब आंसर में कोई इंटरेस्ट नहीं है। तुम देखो 1-1 मेनी वन, तुम सिर्फ मेरे को इतना आंसर दे दो, ये तो तुम कहीं से भी देख के मेरे को दे ही सकते हो, वो तो बात नहीं है। आई एम मोर इंटरेस्टेड इन द कॉन्सेप्ट, लाइक डिड यू सॉल्व इट और नॉट? क्योंकि ऐसे तो हम इसको डायरेक्टली चेक करके ही देख सकते हैं। या शायद दैट इज व्हाट आई एम सेइंग। ऐसे तो if you want to check this whether this is 1-1 or many one, we just have to simply put some values, because these are easy functions. So we will put some values, and in that way we can identify that the given function is many one. So this is mod x. Mod x money, if you put 2 or if you put -2, both will produce the same result, which is 2. So modulus basically gives us the positive answers only. If you give x some negative value, this mod will convert that negative into positive. And if you give x a positive value, this modulus has no effect on the positive values. So the job of modulus, or the objective of this modulus, these bars, is basically to make everything positive. If there is something inside it which is negative, it will convert that negative thing into positive. And if there is something positive value inside this, then it has no effect on that, because its job is to only convert negative values into positive values. So we can easily identify that, but we have to solve this. Shahid, but we can't solve it like this. No. I mean, you are absolutely correct. I understand that you got it. How when will we define the function is 1-1, and when will we define the function is many one? So you can check by putting some values, but this is not the way CBSE or NCRT would want you to solve this question in the boards. In the boards, you will have to consider x1 and x2 only.
Sir, here this one is 1-1, right?
Which one?
First one.
7th.
Yes.
No, 7th is many one. Because if you give this value, I mean, put x as 1 and put x as -1. So f1 is also 1 and f -1 is also 1. -1 रखेगा मॉडुलस के अंदर तो 1 ही कर देगा ना उसको, पॉजिटिव बना देता है ना मॉडुलस हर चीज को।
Yes.
तो many one तो ये है, this is clearly many one, but how do we prove that? The question is this. Shahid, did you get it? What I'm saying?
Yes, sir.
So हमें we have to prove this. I mean, we can't show it like this. But yes, that is good to know that you understand that. तो अपना चेक करने के लिए for you to know, Faiz, I got it. For you to know, this is an important step, that you can check, you can put some values, and you can check whether the given function is 1-1 or many one. Now you know the answer is many one. This function is many one, but now you have to prove this. Now, how do we prove this? Austin, do you have a solution for 7th or 8th? Okay, let's start with our two standard lines that consider x1 and x2 belongs to the set of domain. The set of domain here in this case is this, which is basically the set of real numbers. So consider x1 and x2, which belongs to the domain, which is basically R. Now let's assume that fx1 is equals to fx2, which means that mod of x1 is equal to mod of x2. Mod of x1 is equal to mod of x2, right? And now the important question is how to remove modulus. There are two ways to remove modulus. Either you remove modulus and you put plus minus on the opposite side. This is one way to remove modulus, but this is not considered a good way. One way is that, let's say, okay, I'll show you what I'm saying. Let's say it is written that mod x is 3. So what you can do is you can remove mod and you can apply plus minus to the other side. One way to solve is this, but this is not considered a good way. Why? Because this can get failed. Now let's say, so in the first case we are asking you what is the value of x such that if I take the mod of x, the value is 3. This was the statement of first question, that what are the values or what is the value of x on taking mod we get 3. So we said that, okay, if you take x as 3 or minus 3, then the modulus of both of them, either 3 or minus 3, will give you 3, which is correct. But in the second case, if you apply the direct mathematical rule that remove mod and apply plus minus to the opposite side, then you get the same result. So this plus minus will become minus and this minus minus will become plus. So I've written it like this, minus and then plus. So this is also giving you the same answer. Plus minus likho ya minus plus likho, both are same thing. Either it is plus minus or minus plus, both are same thing, right? But now understand, this is conceptually wrong. Can someone tell me why this is wrong? The second question. In the
Sir,
first one, yeah, Shavis, please.
what cannot be negative?
Mod cannot be negative, right? So mod x, when you say that mod x is minus 3, this in itself is wrong, an incorrect statement. Mod x can never be minus 3. But if you think only mathematical way, तो तुम बोलोगे यार just remove mod and apply plus minus. But you can't solve anything. I mean, you can't solve it like that. This is not a mathematical approach. First, you have to understand the concept that modulus can never give you the negative answer. Mod x can never be equal to minus 3. So as soon as they say that what is the value of x on taking mod of which you get minus 3, you stop them right there. No, buddy. I can't get minus 3 after taking a modulus of something, of anything, right? So this method is considered to be, I mean, this is good, but this won't work in every case. So what's the other method? So to remove mod, you just square both sides. To remove modulus, to remove modulus, you can square both sides. So in this case, on squaring both sides, this becomes mod of x1 ka whole square, mod of x1 whole square, which is basically equal to x1 square. And this becomes mod of x2 whole square, which becomes x2 square. By using the property then that x square and mod x whole square both are same. You can understand that easily, that 3 ka square या minus 3 square both are same. So modulus, what does modulus do? Modulus basically changes the sign. But when we square, we don't care about sign. Either it's 3 or minus 3. The square of both the things are same. So that is why if we square a thing which contains modulus, you can just remove modulus. You can just remove modulus directly. So rather than writing it mod of x1 ka whole square, rather than writing it like this, we can even write it as simply x1 square. So it becomes like x1 square is equals to x2 square. Now we can solve this. Now you know you have already solved it. You get two solutions. One is x1 is equals to x2. And another is x1 is equals to minus x2. So we don't need to check for this one, but for this we need to check. How do we check? Put a value of x2 from the given domain. The domain was all real numbers. So take any real number. Let's take 2. So if I take x2, or let's take 100. So if I take x2 as 100, what is the value of x1? Minus 100. Right? And does minus 100 belong to set of real numbers? Absolutely. Why not? Yes. Hence, both of the solutions are valid in this situation. And when both of your solutions, or rather more than one solutions are valid, then we call that function as the given function is many one, but we have to prove that. Okay, next one. Let's try next one. We should prove the 8th question also like this. And also this is the last question on 1, 1 and many one. This 8th question is the last one. Then we will proceed to into and onto. But before that, please solve 8. Now 8 is the longest also in the series of this. So first question is, how do we start? So we will take x1 and x2. Okay, do you know these kind of functions? This is written fn is equals to n plus 1 by 2 if n is odd, and n by 2 if n is even. So do you understand what does this mean? How many people understand? Just raise your hand. No, just raise your hand. The people who understood the meaning of this function, just raise your hand. Okay, cool. Now you all three can start solving. And for you guys, I will just give a hint. I'll just give a hint. In this case, see, you won't just take x1 and x2. Whatever be the x1 and whatever be the x2, that on the basis of that, we will consider the value of fx or fx1, right? So there will be 4 cases. Either x1 can be a odd number and x2 can be an even number. Similarly, x1 can be an even number, x2 can be an odd number. 2 cases. Third case, they both are odd. Fourth, they both are even. So take all these 4 cases, start solving one by one for each case, and each case should represent x1 is equals to x2 as the only solution. If there is even a single case, in which you got answers other than x1 is equals to x2, or you got more than one answer, more than one valid answers, then the given function is many one. So all of you three, please start solving it like this. Take 4 cases, either x1, first take x1 and x2 both are odd numbers. Then take x1 and x2 both are even numbers, and solve accordingly. For the other 3, Mahmuddin, Tarif and Faiza, guys, what is this? So इसके यहाँ पे हमारे सामने लिखा हुआ है fn या तो n+1/2 होगा अगर n ऑड नंबर है, या फिर fn n/2 होगा अगर n एक इवन नंबर है। सो अंडरस्टैंड इट माने fn की दो वैल्यूज है। fn रिप्रेजेंट्स टू एक्सप्रेशंस। It depends on the value of n which expression is valid. So whatever expression is valid, it only and only depends on the value of n. So for example, you want to find f1. We guys want to find f1. Now, what does this mean? We are putting n as 1. We are putting n as 1. See, the domain is natural numbers only, so we can only put natural numbers here. So we can either put n as 1, 2, 3, 4, 5, 6, up to 100 or up to whatever value you want, right? Now, if I want to find f1, it means that I am giving n the value 1. And what is 1? An odd number or even number? An odd number. So f1 will be calculated according to this formula. Now let's say if I want to find out f2. So f2 will be find out using this formula. Why? Because now 2 is an even number. So whatever is the value of n, the expression for fn will be dependent on the value of n. If n is odd number, your answer will come out from the first expression. And if n is an even number, whatever even number it is, either it is 2, 4, 6, 8, 10, 12, 100, 200, 1000, whatever it is, your answer would be from this. Okay ji. So it means that. So what I am saying is, so let's say अगर आपने अभी x1 and x2 दो कोई numbers उठाए, let's say you say that x1 and x2 are two numbers. So how do you start the question? Like this only. That consider x1 and x2 both are from the set of natural numbers, right? Consider x1 and x2 both are set of natural numbers, and let fx1 is equals to fx2. तो यार पहली प्रॉब्लम ये है कि fx1 की वैल्यू क्या है? fx1 की तो दो वैल्यू है, n+1/2 and n/2. So which expression is valid in this case? But we have just talked about that whatever expression is valid, that depends on the value of x1. So first of all, we need to define what is x1. That is why we will form four cases. Now let's start with first case. x1, x2 both are odd numbers. If x1 and x2 both are odd numbers, then we know what is the value of fx1. The value of fx1 will be calculated by first expression, which is n+1/2. So instead of n, you replace n with x1. And similarly, x2 is also an odd number. The value of x2 will be x2 plus 1/2. You can cancel out 2, 2. You can cancel out 1, 1. So the only solution left for the first part, in which x1 and x2 both are odd numbers, is x1 is equals to x2. So according to the first condition, the given function is 1, 1. But we have four cases. Now let's come to second case. Let's assume that both of x1 and x2 are even number. If they both are even number, second expression will be valid for the function, for defining the function. So fx1 would be x1/2 and fx2 will be x2/2. So fx2 will be x2/2. Yeah, please feel free to ask.
Here also it is 1, 1.
Here also it is 1, 1, right? Because 2 gets cancelled out with 2 and we are only left with x1 is equals to x2. Now let's come to the third case. Consider one of them as odd number. So let's say x1 is an odd number. And x2 an even number. Now if x1 is an odd number, the value of fx1 the value of fx1 is x1 plus 1 by 2. The value of fx2, because x2 is an even number, so value of fx2 is this. You can easily observe the 2 gets cancelled out with 2, but x1 plus 1 is equals to x2 this time. This is producing a result different than x1 is equals to x2. This time the result is different. No, this time the result is x1 plus 1 is equals to x2. So this third condition, now let's check whether this is valid or not. How do we check? Take any value of x2, any value, whatever you want. Okay, let's take x2 as 2. Then what is the value of x1? Okay, x2 has to be an even number, right? X2 has to be an even number. You have already considered that. So you can take any even number, either 2, 4, 6, 8, 10. So let's take 2. If I take x2 as 2, then x1 is 1. If I take x2 as 4, then x1 is 3. What does that mean? It means that 1 and 2 will produce the same result. 3 and 4 will produce the same result. 5 and 6 will produce the same result. You can check this. You can even check this. You have the function. So this third case violated the condition of 1, 1 function. Hence, this function, the given function, is many one. And that you can easily observe as well. If you put x1, oh sorry, if you put n as 1 and n as 2. So if n is 1, f1 is your 1 from this expression, f1. And if you put 2, then you will put 2 in this expression. This is also 1. So 1 and 2 produces the same output. Similarly, 3 and 4 will produce the same output. Similarly, 5 and 6 will produce the same output. Works like that.
Sir, is there any fourth case?
No, there is a fourth case as well. X1 is even and x2 is odd.
It will be
And
same.
that would be same. Yes. In that case, we will get the answer x1 is equals to x2 plus 1, which is exactly the same. If you put x to 1, then x1 will be 2. So 1 and 2 produces the same result. Similarly, 3 and 4 produces the same result. 5 and 6 produces the same result. 7 and 8 produces the same result. So the question works like that. Is it done for everybody? Just raise your hand if somebody is writing. Okay. So did you guys get it? How to identify whether a given function is one or many one?
Yes, sir.
अच्छा शावेज तो चलो आ जाया था. What about others? Okay. What about Faiza? Humamuddin? Okay. What about Humamuddin and Tharif? And Shahid? Okay. Tharif and Shahid? You guys can solve? Okay. Cool. And Shahid, you understood, right? That we can't, we know that we can check this. अपनी understanding के लिए तो check करके देख ले कुछ values रख के. But to prove, I mean, to show that the given function is one and many one, you have to take this approach, x1 and x2. Okay?
Yes.
Okay. मतलब बोर्ड्स में यही करना पड़ेगा, बट वैसे हमें चेक करना तो डायरेक्टली आना ही चाहिए. मतलब ये तो हमें फटाक से निकाल ही लेना है कि वन है कि मेनी वन है. बट बोर्ड्स में यही चल पाएगा यार. बोर्ड्स में इसके अलावा हमारे पास कोई मेथड नहीं है. ओके. तो यार बोर्ड्स, नाउ if I talk about boards, so this is one of the important part. Earlier we need to find the inverse of a function, but now inverse of a function is not in your syllabus. Okay, let's check the syllabus once before we proceed. Yeah, one-to-one and on-to functions only. So earlier it used to happen that we need to solve for whether the function is invertible or not, and if the function is invertible, then we will find the inverse. So what is invertible? Invertible means that whether the inverse function of this function exists or not. For example, inverse of sin x is sin inverse x, right? Similarly, inverse of cos x is cos inverse x, and they both of them exist. I mean, sin x also exists and sin inverse x also exists, but this cannot be said for all the functions. So to find the, yeah, sorry, I did not get you. Please ask again.
It is 1 then only it will be
If the function is 1 and onto, then we say that the function is invertible. Any function which is 1 and which is onto can be, I mean, for a function which is 1 and onto, we can find out the inverse function. So to check whether a function is invertible, we check for 1 and onto. So one step is done, but that is not in the syllabus now. So instead of that, they, I mean, बस थोड़े से steps से reduce हुए, otherwise the methodology is same. Before also we used to find out for 1 and onto. Now also we will only find out 1 and onto. Before, earlier it used to happen that after finding out whether the function is many one or 1 and onto or into, you have to solve for 2 marks more. But now what would happen is the question will be only for 4 marks, and you will only check whether the function is many one or 1, like this x1 x2 wala rule. And the second thing is you will check whether the given function is onto or into. Acha ji. This was, yeah, right. Okay. So let's come to the last topic of this chapter. Many one, oh sorry, my bad. Into or onto.
Sir, can you just like last class notes can you send?
Notes you can take these notes, just inform someone from management and ask them to send you a PDF of notes. They'll send you.
Yes.
And if not, then just contact me. Tell me in the next class. I mean, I have already told them that if someone is not present and they ask for the notes, provide them. So don't worry, you will be provided the notes. Okay, so let's come to the next two types of functions, which are onto and into. First of all, let's understand what are into and onto function. For example, yeah. So okay. Let's first of all just understand what's the meaning of onto and into function with a function itself. So it is given to us that a function is f defined from natural numbers to natural numbers. What does that mean? We can only input the function f natural numbers. The input will be natural numbers and the output can be any natural number, right? And your function fx is given as x square, right? So abhi aap, right now you can only put x as some natural number. Let's start with giving natural numbers. So the first natural number is 1. Okay, let's check it like this. I'm making a table of input and output, right? So this represents what? What does this set represents? Can someone tell me? Fatafat, quickly. What does this set stands for? N, natural number. What does it represent here? Domain, codomain, range. What is it?
Codomain.
No, it's not domain, Austin.
I said codomain.
It's codomain, right? And the first one is domain.
It's a range, right?
The first one is domain and the second one is codomain. Codomain is basically the set of all possible answers. Set of all possible answers, money that any natural number can be your answer, right? Now let's first find out. This is a very mechanical step, manual step, but I'm just showing it for your understanding. So what are the inputs that we can give it? Either input can be 1, input can be 2, input can be 3, input can be 4, 5, 6, 7, 8, 9, 10, right? These are the inputs. And similarly, it will increase. So let's say if I give it the first input 1, the output is 1. For 2, it is 4. For 3, it is 9. For 4, it is 16. For 5, it is 25. Right? Now, understand. What is the range of this? Can someone tell me what is the range of this function? You know the codomain. Codomain is n, set of natural numbers. But what is the range of this function? Anybody? Are galat, you are more than welcome to give me a wrong answer. Please.
Outputs.
Yeah. Set of outputs is basically the range. Whatever we have written in the outputs, that is range. So the range for this question or for this function is 1, 4, 9, 16, 25. Austin, did you get it? This is the range. Okay. So range are basically वो outputs हैं जो मिल रहे हैं हमें और कोडोमेन जो मिल सकते थे वो तो सब कुछ कोडोमेन में आ जाएगा और जो मिला वो हमारा रेंज में आ जाएगा. अब हमें कैसे पता चला मिला ऐसे पता चला क्योंकि इनपुट हमें पता है ना क्या क्या हम पुट कर सकते हैं. The inputs that we can give is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and similarly more. And the outputs we get on these inputs are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. Similarly, like that. अभी मेरी एक बात समझो. Okay. Understand the difference between onto and into functions. So in this case, your range does not cover all the natural numbers. See, 2 is not an answer. 3 is not an answer. 2 and 3 could have been the answer, but they are not. So this time, जो भी range आया, whatever is the range, that is a proper subset of codomain. Range is not equal to codomain. Range is a subset of codomain. Because 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, 23, 24 are not the answers. These are not the answers. They were the possible answers, but these are not the answers we get after putting the input. We will never get 2. Why? Because 2, if I want to get 2, I will have to put x as root 2. If I put x as root 2, then the answer will be 2. But can I put x as root 2? No, because root 2 is not a natural number. Can I put x as root 3? No, because root 3 is not a natural number. Right? So I will not get all the natural numbers as answers. All the answers will be natural numbers, but all the natural numbers will not be the answer. Understand the difference. जो भी आंसर आएगा वो एक नेचुरल नंबर होगा. जो भी आंसर आएगा वो एक नेचुरल नंबर तो होगा. But don't say that all the natural numbers, we have covered all the natural numbers. No, we didn't cover all the natural numbers. But whatever is the answer, that is a natural number. That is true. Right? Just give me a minute. Yeah. So all the natural numbers are not answers, but all the answers are natural numbers. That is a different thing. They have to be from natural numbers, no? Otherwise, what is the meaning of codomain? Codomain only tells you the set of all possible answers. So whatever your answer is, that shouldn't be apart from natural numbers. That is not even possible. You can't find out any answer which is not natural in this case. So codomain is the set of all possible answers, but range is the answers that you get after putting your input. So in this case, you can clearly observe these are the values which are not answers. They are not or rather I should write it like that. They are included. They are included in the set of domain sorry, they are included in the set of codomain, but not, there are more values to this, right? They are included in the set of codomain, but not in the set of range. Which implies that range, whatever is the range for this function, that is a proper subset of codomain. Which, what does that mean? That the given function is into. Right? The given function is into. Now, take one more example. Let's take the same example for real number to real number. Now all the, sorry. Okay, we have to take this as real positive. This means that all the positive real numbers. All the positive real numbers. With 0 also, obviously. So if I consider this and fx as x square, then this is onto. Why onto? Because x square can take any positive value now. Abhi mein x ko, I will not only put x as some natural number. I can also put root 2. I can also put root 3, root 4, in fact, anything. So it will cover all the positive real numbers now, right? Because the range right now is from 0 to infinity. It can take any value from 0 to infinity, whatever you want to have. So suppose you want the value to be 2.5. Let's say, okay, मेरे को output दिखाओ 2.5 कैसे आएगा? तो रख दे root of 2.5. Whatever you want to have. तुमने कहा I want to have 3.78. तो रख दे, put the value of x as root of 3.78. I want to have the value 4.0111. Okay, put the value of x as root of 4.0111. So whatever you want to have now, you can have that output, but you know that the output has to be positive only. Output has to be positive only. So R plus money set of positive real numbers. And plus 0 also. R plus 0, because 0 is neither a positive number nor a negative number. So we have to write 0 separately. Or we can also write it like all real numbers except R negative, which means that all real numbers, just subtract all negative numbers from the set of real numbers. So you are left with positive numbers and 0. Anything. Right? So now this function is onto. So this is how it works, into and onto. Now, to find out into and onto, you first should know how to find out range. So codomain will always be given. We always know what is the codomain of the given function. So we always know about codomain, and if codomain is not given, then we consider set of real numbers as the codomain. If codomain is given, good, it will be given in 99% of the cases. And in 1% cases, when it is not given, what do? You consider R, set of real numbers, as your codomain. Right? So find out the range of function and compare it with codomain. And compare it with codomain. So the main step is अंकित हो गया बस खत्म हो गया बस मेरे पास ठीक है compare it with the given, compare it with the codomain. This is the important step. So to find out into onto, you should know the range of function, which we have discussed in class 11, but we will discuss it one more time to make you understand how to find out the range of function. So if we are good with finding out the range of a function, then we can always solve it. We can always find out whether the given function is into or onto. Right? And I mean, with this, also note that codomain is generally given. Codomain is generally given for all functions. And if not given, then consider R. What is R? The set of real numbers. as the set of codomain. So in most of the cases, it will be given. But if it is not given, you always remember that R, set of real numbers, is the set of codomain. Because set of codomain is basically represents set of all possible answers. So your answers must be from real numbers only. Because you are studying real function. We do have, in the initial, we have two different kind of functions, real functions and complex functions. So real function are those functions in which the answer is a real number, and complex functions are those functions in which the answer can be either real number or complex number. But complex number is not in your syllabus, even in JEE. It comes in undergraduation syllabus. अगर कोई engineering करने वाला है यहाँ पे, if you are thinking about doing engineering, then you will be studying about all those things which I am talking about right now. But you don't need to know about complex functions much. We are studying real functions, and real functions are those functions in which the answer is from a real number. So the main point is, the important point is that codomain is generally given for all the functions. But if it is not given, then you consider R, set of real numbers, as the set of codomain, right? And last year what happened is, last year this happened actually. One question was there in which it was basically on this only, that you have to find out whether the function is onto and into. The question was similar to this. You have to identify whether the given function is onto and into, and they didn't give the codomain, set of codomain. So everybody asked to cancel the question, like the information was incorrect. But no, the information was correct. Because if there is no codomain given, then you always consider R, the set of real numbers, as the set of codomain. And it has exactly happened like that. I mean, a lot of my students registered for this complaint query. And some of them actually got the answer right, because they know that if we are not given with the codomain, then R is the set of codomain, right? Okay, so we will understand how to find out the range of the function. If we are good with range of the function, then we are good with into and onto. There's nothing new in this. Also, I would urge every one of you to just study about how to find out range of the function. I'll teach every one of you, but just take a look about this range of function, okay, before coming in the next class. चलिए फिर टाटा बाय बाय, मिलते हैं next class. We'll be having probably an extra class in this week. Okay, we'll inform you when that extra class will be, according to your other classes. Yeah, Shavis.
Sir, like if range is equal to codomain, then it will be onto.
Yes. If range is equal to codomain, then it is onto. If range is not equal to codomain, so that is basically range is a subset of codomain, then it is called into. ठीक है, चलो फिर ओके, मिलते हैं नेक्स्ट क्लास.